We will soon see some short sentences in a made-up language called Wakanti. Note that the long consonants are written as double letters to make the analysis easier. Here are the words relevant to this topic, and the words in quotes are the corresponding English meaning. In addition, the words in the right column are the negative cases of the words in the left column. Question A asks, what is the phonemic form of the phonetic morpheme based on this data? Question B then asks, what are its allomorphs? Question C asks us to state a rule that derives the phonetic forms of the allomorphs from the phonemic form. Question D asks us to find another phonological rule that applies to this data, and to state to what natural class of consonants the rule applies. Lastly, question A asks us to give the phonemic forms for all the negative sentences. First, we compare the words in the two columns to try and find the negative morpheme. We find that the words in the right column have the extra parts in red, which happens to be inserted after the first segment. Thus we know m, n, and ng are the three allomorphs of the phonetic morpheme. However, for the three pairs in the right box, we can see that parts colored in violet on the right are no longer the b, d, and g in original forms. In other words, if we cover up the negative morphemes, we see that the word stems are not the same. For now, we treat them as special cases, and we will find a way to explain them later. Step 2. Observe the phonetic allomorphs and check their environments. Here the three allomorphs are marked in different colors, and the forms immediately following are marked in violet. Since our focus now is on the environments of the three phonetic allomorphs, we ignore the left part of the data and rearrange the right. Here is the result after rearranging, split into three groups. After observing, we see m occurs before m, p, and w, which are bilabial sounds. Ng occurs before ng and k, which are velar sounds. And n occurs before these six sounds. However, these sounds do not share any particular properties. Step 3. Determine which of the three allomorphs is the default. First, we list out the results from the previous step. After observing, we see n has the widest distribution, and it can occur before consonants which are neither bilabial nor velar, as well as occur before vowels. So, n should be the default and also the phonemic form. Step 4. We find a rule that can account for all three allomorphs of the phonetic morpheme. After observing, we see that the homogenic nasal rule can be used, which says n assimilates to the place of articulation of a following consonants. For example, when n is followed by velar sounds like g, k, or ng, it assimilates to the homogenic ng. But when n is followed by bilabial sounds like b, p, m, or w, it assimilates to the homogenic m. Here we explain again using the table of consonants. When n precedes velar sounds, it assimilates to ng. And when n precedes bilabial sounds, it assimilates to m. This is called homorganic nasal rule. Here is an extra note. If we look carefully at the table, we see that the W actually is both bilabial and velar, as marked by the boxes in green. This is because the sound W is produced not only by raising the back of the tongue towards the velar, but also by protruding the lips. This means when N is followed by W sound, the N can assimilate to either Ng or M, thus having two possibilities. So in step 4, why do we say that when N precedes W, it assimilates to M and not Ng? In other words, why do we only consider the bilabial property of W and ignore its velar property? This is because in our analysis, we're deriving a phonological rule from the data given, and the data tells us when N precedes W, N assimilates to M and not Ng. For example, the phonetic form of unwilly is unwilly and not unwilly. So clearly, native speakers consider W to be bilabial rather than velar, meaning N assimilates to M when he meets a W. On the other hand, if our data shows that N assimilates to Ng, we will consider W to be velar. This type of methood also derives the phonological rule from the data is called bottom-up, data-driven, or descriptive grammar. In step 5, we now check the 3 special cases. Going left to right, in the first column are the original affirmative cases. In the second column, we insert the phonetic morpheme N. In the third column, we apply the homorganic nasal rule and assimilate N to the corresponding homorganic nasal according to the consonants following it. From our previous conclusion, the phonetic forms should be the third column after applying homorganic nasal rule. However, the phonetic forms are the final column, so there must be a rule to explain why the third sounds change from B, D, G to M, N, Ng, respectively. Step 6. We find a rule to explain the 3 special cases. After observing, we see that the rule of voiced stop assimilation can be used, which says a voiced stop consonant will become homorganic nasal when preceded by a nasal consonant. In facial notations, the rule looks like this. Simply put, when B, D, and G are preceded by M, N, and Ng, they are assimilated to M, N, and Ng, respectively. Here we'll explain again using the table of consonants. When B, D, and G are respectively assimilated to the homorganic M, N, and Ng, we call it voiced stop assimilation. Step 7. Find all the phonemic forms. The data originally given are in phonetic forms, and the left column are the affirmative cases. Because the question did not specify any phonological rules, the phonemic forms are the same. According to our previous discussion, simply insert the phonetic morpheme N into all the affirmative sentences, then we will get the phonemic forms for the corresponding phonetic sentences. Finally, for the phonetic sentences, apply the 2 rules to get the phonetic forms from the phonemic forms. The phonemic forms from the last step are listed in first column, and applying the homorganic nested rule to them, we get the transition forms. By further applying voice-stop assimilation, we get the phonetic forms which are identical to the data given at the start of the topic. The following are answers from the publisher which can be used as a reference.